Hey everyone, let's solve this question. Determine the gradient of the following scalar fields. Okay, the first bit says we have to take out basically over here del v. So this is Cartesian coordinates. So for Cartesian coordinates, how do you take out your gradient? Gradient are all defined for scalar quantities. Okay, you take out the gradient of scalar quantities. So over here, for taking out in Cartesian coordinates, this is what you'll do. Del of u is equal to rho u by dou x a x cap plus dou u by dou y a y cap. Okay, so this is how you do. And this is you can just simply substitute this x square y plus xyz. Okay, so basically if you take out the gradient of a scalar quantity, you'll be getting a vector quantity. Okay, so gradient, if it's asked to take out, then the result that you'll get will be a vector quantity. Okay, so over here again x square y plus xyz. Okay, so this del operator, as you know, it we do the partial differentiation here. Okay, so over here into by dou x, you'll just differentiate x terms, treating others as constant. Okay, then similarly for others as well, square y plus xyz a z cap, this is equal to 2xy. Just differentiate x terms, treating y and z as constants. Okay, y plus yz, this is ax cap. Then again over here, y will be differentiated, others x and z are constants. Okay, so what is it you're getting? Over here, y, so it will become 1. Okay, it's like this. Then plus this one is okay, we are z will be there, it will be differentiated, and x and y are constants, so this is x y a z cap. Okay, so this is what I got. The next bit, okay, see over here in the next bit, it's given in cylindrical coordinates. Okay, for cylindrical coordinates, how do you take out the gradient? Well, it's like this: dou by dou rho a rho cap plus rho d phi a phi cap plus dou by dou z. Okay, so over here you just have to differentiate this. Okay, so what is the question? Rho, okay, rho z sine phi, rho z sine phi plus z square cos square phi plus rho square. This is what we've got. Okay, then 1 by rho dou by dou phi. This again, these all are partial differentiations. Okay, so you know that there'll be just one term that you have to differentiate, and others will be treated as constants. Okay, then plus dou by dou z sine phi plus z square cos square phi plus rho square a z cap. All right. Okay, now just differentiate the first term where rho will be differentiated, others are constant. Okay, then this is z sine phi plus 2 rho, because z square cos square phi will become 0 because there's no rho term over there. A rho cap plus this is 1 by rho and 2. Now differentiate those terms where phi is there, others rho and z are all constants. Okay, then over here this is sine phi's differentiation is plus cos phi, and over here it will be cos square phi, so it will be 2 cos phi sine minus sine phi, you write minus sine phi, right? Then over here this much a phi cap. Okay, then next moving on, plus okay, differentiate z, others are constant, rho sine phi, okay, plus 2z cos square phi a z cap. Okay, then next, moving on, what will you write over here? Okay, let me just write it. Z sine phi plus 2 rho a rho cap plus over here you'll write z cos phi. Okay, this is minus. Okay, this is 2 cos phi sine phi. I can write it as sine 2 phi. Alright. This is divided by rho. Okay, and this much a phi cap. Then plus this one is rho sine phi plus 2z cos square phi a z cap. Okay, then what's the next bit? Next bit, okay, over here it's given in spherical coordinates. Okay, it's given in spherical coordinates, and for spherical coordinates, how do you take out the gradient? Well, basically, okay, what will you do? Dou by dou r a r cap plus this is dou by r dou theta a theta cap plus this one is r sine theta dou phi a phi cap. Over here f is given over here. Okay, all right, now in the question, what's given over here? F's value is cos theta sine phi ln r plus r square phi. Okay, then a r cap plus this one is what? R dou theta. Then over here cos theta sine phi ln r plus r square phi. This is a theta cap. Then this one is dou by r sine theta dou phi. This one you'll write over here cos theta sine phi ln r plus r square phi a phi cap. Okay, so what will you write over here? Okay, in the first term over here r, you have to differentiate r, and others will be constant. So cos theta sine phi ln r's differentiation is 1 by r. Okay, then plus 2r phi. Okay, this is done. This is a r cap. Okay, then next term will be, okay, over here what will be constant? Theta will be has to be differentiated. R and phi are all constant. Okay, then over here what will you write? Okay, cos theta is there. Cos theta's differentiation is minus sine theta. So this is sine phi ln r. The next term is 0 because there's no theta term over there. A theta cap. Okay, then plus over here you have to differentiate phi terms, and theta and r are constant. Okay, so over here what will you write? Cos theta. Okay, sine phi's differentiation is cos phi. This one is ln r, and plus this is r square. This is a phi cap. Okay, let me just simplify it a bit. Cos theta sine phi by r plus 2r phi a r cap. Okay, minus this one is sine theta sine phi ln r. Okay, whole divided by r. Okay, a theta cap. Okay, then next term over here, if I get this inside, I'll get, okay, sine cos theta by sine theta is cot theta, and this is cos phi. This one's ln r. Okay, divided by r. Okay, plus r square. Okay, 1 by sine theta. I can write over here cosec theta. Okay, this much a phi cap. Okay, so all right, this was the answer for this. Okay, you must know how to take out the gradient for this sort of questions, and just solve these questions in order to practice. Okay, thank you. That's all for this video.